Hello. So over the last couple of videos, we've been talking about the angle addition identities for trigonometry, and I'm going to write those out really quickly. We have that the sine of alpha plus beta is going to be equal to sine of alpha cosine of beta plus sine of beta cosine of alpha, right? We have that the cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a, or alpha, times the sine of beta, not b. I might have been saying b. I do that a lot. We also have that the tangent, and you can find this by just dividing one by another, but it's often good to know the tangent angle addition identity just because it's a little bit more direct, but you don't necessarily need to. It might be easier if you do. Tangent of alpha plus beta is going to be equal to tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. So that's all fine and good, but what if we want to subtract angles? And there are examples in which that will be important, which I'm going to show in the following videos. But let's say we're subtracting an angle. Well, what would that be the same as? Because, I mean, what we're really doing is adding a negative, right? So if we're trying to find sine of alpha minus beta, that's really the same as finding the sine of alpha plus negative beta, right? So then we should be able to just plug that into each of our formulas, a negative beta, and see what their formulas are for angle subtraction. So let's start with sine, since we're already here. That's going to be, and let's wall off this area. So we're done with this angle addition over here. So this is going to be, let's see, sine of alpha, which is still sine of alpha, times the cosine of negative b plus the sine of negative b times the cosine of alpha, which is the same as cosine of alpha. So what's a cosine of negative b? What's that? Well, that's just going to be cosine of b, since cosine is an even function. If you plug in negative values of that angle, you're going to get the same output. So cosine of x is equal to cosine of negative x. And you can verify that on a unit circle. So this first expression here is going to be sine of alpha cosine of beta, just like before. But what's sine of negative beta? Now you're going to find, because sine is an odd function, sine of negative beta is actually negative sine of beta. So this is going to be the same as negative sine of beta times the cosine of a. And there we have it. This is our formula. I think that's kind of neat. Let's try for cosine. Switch colors. And we're going to write this all out in perhaps a more concise manner a little bit later. So the cosine of alpha minus beta, well, let's plug those in. It's going to be the same as here. Maybe I'll even separate it out. I want to make this as clear as possible because it's not complicated. This is just plugging in new values, right? Because sine of alpha minus beta, or sine of alpha minus beta, or cosine of alpha minus beta, is going to be the same as that function of alpha plus negative beta, which is going to give us, at least for cosine, that's going to be, let's see, cosine of alpha times the cosine of negative beta minus the sine of alpha times the sine of negative beta. Yeah. And let's just look at what we did again. Sine of negative beta here is going to be negative sine of beta, so that negative is going to cancel out with the one that we have right here. And this one is just going to stay the same, right? Because cosine of negative beta is the same as cosine of beta. So I kind of already wrote it out, but our answer is going to be cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. And you'll notice that when we're adding, there's a subtraction sign in the middle. And when we're subtracting, there's an addition sign in the middle. It might be a little bit counterintuitive, but we're going to sum that all up at the end. Let's do tangent first. So we're going to get to tangent now. This is our final function. We're not going to get into, any inverse functions and stuff like that, because that's not what we're dealing with right now. And that would take some extra time in terms of secant and cosecant and stuff. Though, obviously, you can just flip it. There's no point in writing that out. So let's separate this again. Get our lovely, dark pink, or whatever color this is. Tangent of alpha minus beta is going to be equal to, let's see, what's our formula? Well, first of all, this is going to be tangent of alpha plus negative beta, right? So if we plug that into our formula, that's going to be tangent of alpha plus tangent of negative beta divided by 1 minus tangent of alpha times the tangent of beta. Look how nice that is. All right, now we have to think about even and odd functions again. Basically, whether if we plug a negative value in, it's going to stay the same or switch signs. So as we know with the function sine, actually, when you plug in a negative value, that's the same as taking the negative function of the positive version of that value. So sine of negative b is the same as negative sine of b, right? We saw that up here. This one to here. And tangent, as you well know, is the quotient between the sine and the cosine. And cosine of a negative value still stays positive. So cosine of x is the same as cosine of negative x. But the sine of negative x is going to be negative sine of x. So that this whole tangent, this tangent of negative b here, this is an odd function like sine. It's going to be equal to the negative tangent of b. All right, so let's take that into account. Oh, I forgot to add the negative down here. My bad. Now let's simplify that, right? We still have tangent of a. We haven't really changed alpha. We have not, in fact. Tangent of a, that's going to be minus tangent of beta. If you're still confused about that, just think about even and odd functions. We will have some videos out on those in the near future. Divided by 1. Now, is this going to be minus or plus? It's minus right now, but notice we have this negative b right here. So that's going to turn this expression into a positive because the negatives are going to cancel out. So this is 1 plus tangent of alpha, tangent of beta. And that is going to be our formula for the subtraction, the tangent of two angles, one subtracted from the other. Whereas, oh, I never circled my my cosine formula. Here we go. Everything must be circled, though I wouldn't really call these circles. All right, cool. Now, in a moment, we're going to be looking at perhaps an easier and simpler way to kind of include both these functions up here and all the ones that we just learned down here so that we can have some nice, concise formulas.